All right, let's take a look at a situation which is actually a mass problem. So the last one that we did together was the same exact chemical reaction, but we went from moles to moles. This time we're going to add a layer, and I'm going to start with grams. So the problem here says that you're given 5 grams of nitrogen gas, and they want to know how many grams of sodium azide you have to use in order to get there. So again, I'll solve it 2 ways. We'll take a look at method 1, which I filmed at the same time, so it got cut off again. Method 1 is the factor label method. So we'll start with what we know. We start with 5 grams of the nitrogen gas. And now I need to get rid of grams and get to moles. So I'm going to take 2 times 14.01, which is on the periodic table, the molar mass of nitrogen. And that'll be 1 mole of nitrogen gas. And now I have moles of nitrogen gas, but that's not what I want. I need to get to moles of sodium azide. So I go back up to my balanced equation, and I know that 3 moles of nitrogen will produce 2 moles of sodium azide. So now my moles of nitrogen are going to cancel, and I have moles of sodium azide. So I want to get to grams of sodium azide. And if I look up on the periodic table, sodium has a mass of 23. And I have 3 nitrogens in there, so that they each have a molar mass of 14.01. So that will work out to be my molar mass of the sodium azide. And so now I'm left, if I cross out all my units, I'm only left with grams of sodium azide. And if I do the math on that thing, I'm going to get 7.74. Even though it looks like I wrote 7.44, it's 7.74 grams. And again, my problem started with 3 significant figures, so I have to give 3 significant figures in my answer. Let's move on to method 2. Method 2 is going to be our Bca table again. So I rewrite my chemical equation. And I write my before, my change, and my after. And I'm going to split the before and the change, the change and the after, so that I know what my final products are. Up at the top here, I'm writing my 5 grams because in a Bca table, the only thing that belongs as numbers in there are moles. So if you're given grams, you cannot include them in a Bca table. So underneath my Bca table, I'm going to convert my 5 grams of nitrogen gas into moles by dividing by the molar mass of 2 Ns, or 28.02. That turns out to be 0.178 moles of nitrogen gas, and that is my ending value. The problem says that is what I ended up with. I could have kept more significant figures at this point, but I need to keep 3 because I know that I started off with 3 significant figures in my problem, so I'm going to need 3 significant figures as a final answer. So I don't want to go below 3. I need my ratio again, so I know that I have 3 nitrogens for every 2 sodium azides, and I know that I have 0.178 moles of nitrogen, so I can cross multiply, and that will turn out to be 0.119 moles of the sodium azide. And that's a change, because whenever you're doing the ratios in a Bca table, what you are is you're comparing the changes that occur. I know that in a normal chemical equation, I need to end up with no reactant left. So what did I have to start out with in the beginning? Well, I must have started off with 0.119 moles, so that when I had my change of 0.119, I ended up with nothing. Now I want to convert those moles into a gram, so I'm going to multiply by the molar mass of sodium azide. And the molar mass of sodium azide is 65.03. As we saw in the previous video, it's 23 grams per mole for the sodium, and then 3 14s for the nitrogen gas. And so if I multiply those together, I get my 7.74 grams, and that has the 3 significant figures that I need. So now we're looking at Bca Table, still probably more work than it was method 1 with the factor label, but they're getting closer at this point. In one of the future videos, we're going to introduce a limiting reactant. And once we introduce the limiting reactant, the work that you would have to do for factor label and the work that you'll have to do for Bca tables is probably going to be a wash. So again, if you like factor label method, you can continue to do it. It is a valid way to solve these problems. I'm just giving you a different way to look at things and trying to set you up for the future when I'm going to force you to use something that is almost identical.